So now we have this fine-tuned LLM, and the next challenge will be evaluating numerically how well the model is doing. Because if we have a numeric, let's say, value that we can attach to this model, this will allow us to make progress, right? So if I change hyperparameters here and try different things, try a different model, try a different prompt template, different data set, how do I know that the model is actually getting better compared to this model? So one way would be just as a human looking at these responses, but that would be pretty challenging to do this for a lot of examples and keeping in my head, oh, I feel like this one is better than this other one, and so forth. So we want a more systematic way of evaluating the model. And for that, we need ideally like a score or a number. And so that is what we are going to do in the remaining sections here. So we checked off the dataset preparation, the fine-tuning. Now the last stage is evaluating the model. This comes in 3 steps. This first step, this section will be just concerned with extracting the responses and saving them, so that in the next section I can show you a way to evaluate the responses that we have saved. So the code for that is relatively simple. We are going to just use our generate function to generate new text. So the text that the model receives is the input text for each test sample. So here, just for simplicity, I'm iterating over 3 test samples. So let me test data. It's data that the model has not seen before. And so we are formatting it similar to before. We use the model to generate the response. And the response text is then also cleaned similar to before. So we are stripping out the input so that the response doesn't include the input that was already there. So we're stripping out this one. And then we also remove the response tags so that it looks like nicely formatted text. And so let's just see how that looks like. So here we are looking at the first response, and the instruction is rewriting the sentence using a simile. And here the input is the car is very fast, and one potential response, the one that is provided in the test set, is the car is as fast as lightning. And the model response is the car is as fast as a bullet. So I would consider this to be a good response. So I would say here the model, it didn't exactly write as lightning, but I feel like this is a similarly good response. So this would be valid in my view. Looking at the second example, the instruction is what type of cloud is typically associated with thunderstorms. The correct response is, I don't know how to pronounce it, but maybe cumulonimbus. And then the model response is cumulus cloud. So here, I'm not an expert in clouds, but I think the model made a mistake. So here the model generated essentially this answer, where I think this is the correct one. So, however, I would say the model is still, it's generating something. So it's not just gobbledygook. So if we go back to an earlier stage here where we had the model, it was just generating part of the input. It didn't make sense at all. That was the pre-trained model. So I feel like our fine-tuning did something useful. So the model is at least responding in a human readable way, but the answer is not necessarily correct in this case. And the last and third one here is, the instruction is name the author of Pride and Prejudice, and the correct answer is Jane Austen. And the model writes the author of Pride and Prejudice is Jane Austen. So I think this is, I would say this is the correct answer. It's just a bit more verbose. So the model uses more words or more tokens, and this is fine. This is, to me, a correct answer. But you can see the challenge now. How do we evaluate that, right? So here, how do we check that this is correct? Because you can see there's a slight difference, right? You have this versus this. Maybe you can write an automated way of doing this, writing some code, but then how do you deal with cases like this where you have a different word and in this case it's not correct, right? And so this will be the challenge of the next section. I will show you a way of automatically evaluating it. The gold standard, of course, is to have a human expert going through these and then figuring out whether these are correct, but that would be a lot of work if we have hundreds or thousands of test samples. So For this section though, for the remainder, I will just save these responses here so that we can reuse them later in the next section. So for that, what I'm doing is I'm using the TQDM progress bar library. And here in the progress bar library, what I'm doing is I'm iterating over it, setting the length to the size of the test set. So this will make a bar that is as long as the test set. I think it's 110 examples. And then here, this is exactly the same code I have above here, where I'm just using the format, the generate, and then the preparation. And the one new thing that I'm adding here is that I'm assigning this response to the dataset instruction so that we can save it to the JSON dictionary. So let me execute this, and I can talk a bit more about this because this might take a few minutes. So here, what it is doing is essentially generating all the responses for the whole data set and then just saving them. So if I go up again, maybe to the top of this notebook, when we looked at the data set, it had only 3 fields: instruction, input, and output. And now we are adding this field model response for each of these entries, and then I'm saving this. The reason why I'm doing this is because in the next section, I will show you a tool that I recommend. I mean, you don't have to, but you can run it outside this notebook. You can, for example, even run it on a different computer, but for that you would need the dictionary, right? You need to model responses. One way could be, of course, generating them on the fly, but it's not a bad idea just to, since we have the model here in memory, we have trained the model, it's sitting in our Python session actively, so we can just use that model since we have it and generate all the responses, and then we can shut down the model. We don't need it anymore. And yeah, I'm seeing that's also why I like TQDM as a progress bar library. It's estimating it takes about 8 more minutes, 7-8 more minutes. So maybe I will just make myself another tea or sparkling water, and we'll be back in a few minutes then. So the model has finished processing our test data set. So let's take a look at one of those. And see how it now looks like. So similar to before, we have the entries instruction, input, and output. And then we have also now the model response. So we have that now for the whole test data set, which consists of 110 examples here. One more thing before we move on, since the training and everything is quite expensive, before, let's say, we evaluate the model in a new session and, things might happen, things might crash or something like that. It's never a bad idea to also save the model. So here, this is just some boilerplate to save the model with a respective name. In this case, if we experiment with a 124 million and 355 million version, this will use the model size as the name dash SFT for supervised instruction fine-tuning. So I should say this is also jargon. SFT stands for supervised fine-tuning, and it's just like a different word for instruction fine-tuning in this context. So some papers, books, they just say SFT, which means doing what we have just done here in this notebook. And so then we are saving it as the model dict like we did in chapters 5 and 6. And if we want to load the model in a new session, we can do it like as follows. So the name here will be GPT-2 medium 355 so and so. So let's just see that it works. So here we can go to our browser and we can see, this has been saved now. It's 1.6 gigabytes. And then, I had this one bonus material that I showed you, this user interface, where you could technically now use this model to build an interface like that if you're curious. So the code is here, and this is loading that model somewhere here. Let me see, load, here. So we are loading that model here if you're curious. Okay, and so with that, we have the model, we have the responses, and then in the next section, I will show you how we evaluate that model.
Get this book at Manning.com.